So now I'm going to be doing a land acknowledgement. In the spirit of respect, reciprocity, and truth, we honor and acknowledge Mohkinstsis and the traditional Treaty 7 territory and oral practices of the Blackfoot Confederacy, Siksika, Kainai, Piikani, as well as the Yaqsi, Nakota, and Tsuut'ina nations. We acknowledge that this territory is home to the Métis Nation of Alberta, Region 3 within the historical Northwest Métis homeland. Finally, we acknowledge all nations, Indigenous and non, who live, work, and play on this land, and who honor and celebrate this territory. So earlier this week, we had our first session on Circular Economy 101. And our guest speaker was from the Recycling Council of Alberta, sharing their zero waste initiatives for municipalities in Alberta. So at the very end, we'll be presenting you with some resources. So if you guys missed that session, you guys can look into that. So today, our panel on circularity of construction materials, what we're going to be going over are just some of the challenges and barriers in that are, I guess, that we're having right now. And we kind of picked this topic because it's very relevant to Alberta. We're a very industrial place, and it's also to kind of think about, like our home materials and our infrastructure and things that we maybe don't really think about, but there's a big opportunity there. So what we're really interested in this session is learning about the opportunities that are out there, whether that's company policies or innovation or applications. So, and I think that's something we may not be really familiar with, especially what's being done in our local communities. And we'd really like to highlight the key people that are advancing this initiative here in our city and in our province. So that's what we'd really like to focus on today. But something I'd like to point out before we start this is that circularity, it's not just about reducing waste. It's actually rethinking the design and the use and the reuse of our products to retain their value and their material properties and design over time. So I think what this really is about like increasing the value of each unit of resource. And I guess I was just thinking, like, during a pandemic, how important that is. Like, we can't just be having, like these Band-Aid and temporary solutions. We need something that has long-term solutions. And things like that leads to, less commodity shocks at times of disruptions and offers that resiliency. So I'll be your moderator for the panel today, and just some background on myself. My name is Adrita Haque, and I'm a mechanical engineer at EIT, and I work at Equinox Engineering. And I also volunteer with the Calgary Professional Chapter in their advocacy team. And I had the pleasure of organizing this event today with Erin Bird, and she is the project manager, yeah, right there, at the City of Calgary. And many of you may recognize her from our first session on Monday. And we also have Eileen Ling, the co-founder of Makeshift Commons. And unfortunately, she couldn't join today because she's in the middle of a big move, but she's very crucial to this event. We also have Lori Farley, the founder of Intonovis, as well as Kai Costatini, and she's the founder of the Circular Economy Club of the Calgary chapter. So now for our panel today, I'd like to get to the exciting part where I introduce our speakers. So first, I'd like to introduce Dan Zembal, and he's the founder and owner of Alberta Waste and Recycling. And his company was actually the first business in Alberta to figure out how to actually successfully recycle asphalt shingles and drywall. And he's also won his business has won the award, the Recycling Council of Alberta's award for construction and demolition leadership in Alberta, and that was in 2011. And he's also founded and is the owner of Poly AG Recycling. And Dan's just led so many areas on this in terms of recycling and improving it through policies, and he sat on many boards for this. So So Dan, I'm hoping you can introduce yourself and just tell us more about the great work you're doing here in Alberta.
Well, thank you for that great introduction. I'll give you a little bit of background on myself. I've got about 25 years in the construction and recycling game here in Alberta. I was past president of the Recycling Council as well. So, and when I was in that term, that was one of the pushes I made, was to look at construction and demolition recycling. At that time, there wasn't a lot of activity in the province. We got the provincial government involved as well as the local municipalities. And today there is a fairly active recycling group that recycles construction waste in Calgary and in, quite frankly, across Alberta. Those initiatives that we started years ago, I guess about 10, 12 years ago, have started to, it's kind of settled into a fairly good place. One of the things that, I mean, there's still materials we can't recycle, and I'll address that in a minute. So Alberta Waste and Recycling, we were one of the first companies, or we were the first company to look at drywall in Alberta and what we can do with it. And we started collecting it and played around with a few different options. And today drywall is for the most part is being used. It's either being recycled back into drywall, which is a very circular thing. And then the second thing it's being used for is as a soil amendment. So that's kind of the main two uses in Alberta. Another thing that we recycle a lot is, so we do a lot of sorting. So we'll get material from the home builders, from the general contractors, and there are a number of different facilities scattered throughout. There now are a number of different facilities scattered throughout the area. Alberta Waste and Recycling has two such facilities, one in North Calgary and one in Airdrie. And we recycle wood, drywall, metal, asphalt shingles. We also get a fair bit, because these bins are placed in new communities, we get a fair bit of what we call illegal dumping. So we get a fair bit of scrap metal, we get a fair bit of tires, paint, used oil. All of the provincial programs we feed into because we get those materials in our loads. So that material is collected, sorted, and then, you know, to the various different directions it goes. So drywall is soil amendment. Wood, we work with and we sort that out, get the metal out, magnetically, and then that goes into either an animal bedding product, or it goes into a compost facility. And those are the two main ones. Some of my competitors also will produce a landscape mulch, and in some cases will color that mulch and ship it Canada-wide and into the US, I believe. We have scrap metal. I mean, scrap metal has been around for a long time, and you know, we do get a fair bit of scrap metal from the construction industry, and that goes to the different scrap metal dealers and then gets processed. Asphalt shingles was fairly active. We started off with an agreement with Lafarge and here in Calgary, and then was a number of others that were also doing it eventually. But that was made into a road material and was typically mixed to make pavement. We were actually doing probably the majority of shingles in the city of Calgary at one time, and the majority of shingles were diverted from landfill after a time. However, the engineering has changed, and they do not allow it any longer in streets. So there are a few other options that it is being used in parking lots and such, but it is limited now. And since about over the past 10 years, I would now say that the vast majority of construction waste does not go to a landfill in Calgary. And the vast majority is recycled. And initially we were aiming for 75%. In reality, you can do that, but economically and sustainably, you cannot do it effectively. There's just some things that it's not worth tearing apart because they're composite or they're mixed materials. I was asked earlier about what are the more difficult ones that you'd like to see, and one of them is and I'm sorry if I'm stealing your thunder, but one of them is plastics, and that is plastics are very difficult to sort once they're mixed. They're very dirty. Typically in a construction setting, they're dirty, and there's so many varieties of plastics that it's difficult to sort from a construction perspective. We've also set up a facility in Bashaw, Alberta, the center, one of the main grain growing areas in Alberta. And we are recycling grain bags. That's another initiative. We are actually taking grain bags from Saskatchewan and Alberta. And that plastic is able to be recycled because it is a single stream, single source for the most part. 7 different manufacturers in the world produce these grain bags. And I guess I just want to divert a little bit into that, in that with polyag, we are able to take that and recycle it into a very usable, marketable commodity product that is shipped worldwide, because it is a clean plastic, or not clean as in, it does have dirt and grain and some stuff on it, but more, it is a single type of plastic. It is a polyethylene plastic, and it doesn't have polypropylene mixed in. It doesn't have PVC mixed in it. It's just one single material made by a limited number of manufacturers, so it doesn't have a lot of mixed material in it. And that is some of the challenges that we have, is that in the construction side, it's so mixed in that, not only is a lot of it composites, but you might have lumber wrap mixed with building wrap, mixed with shrink wrap, all very different types of material. And when you mix all of those streams into a bit of a mess, it's hard to pull that out. And if you are successful in pulling it out and cleaning it, it makes a very, typically a fairly low quality product. So that's, sometimes you can make some plastic lumber out of it, or you can make some, again, you downcycle it to such a point that it still has benefit and still doesn't go into landfill, but it's hard to keep that sustainable. So that's the main spiel that I have. I'd love to. Sorry for stealing that question on you, but if you have any questions, have at her.
No, thank you, Dan. I'm glad you addressed all of that. And I've been really curious to learn more about that. But what I think is really great about the work that you're doing is, like how you've increased the accessibility of these services. Like you mentioned, like when you first got involved with RCA, like wasn't something that's very like a big focus for Alberta. But I think one of the main challenges we actually face is just having accessibility to these services and cost affordable solutions. And like, I think businesses and individuals have good intentions and they want to improve their practices, but sometimes we just don't know where to go. So it's really great to know about how you've really taken that to the next level.
Well, and just on that note a little bit, when we first started, out of about 50 or 60 home builders, 2 were willing to pay more to recycle their material because it costs more. And once the landfill tipping, and that was one of the initiatives that the province promoted, and the city of Calgary in particular, they started increasing their landfill tipping for garbage, and they started looking at incentives or disincentives for diverting that material from the landfill. And when they started to increase their prices, they hit a certain threshold where it became relatively even cost-wise to recycle it or throw it in the garbage in the landfill. And that's when our business across a lot of different businesses came in and offered those solutions. So They were surcharging, material initially. If you had asphalt shingles in your load, or if you had drywall in your load, they would add a surcharge. So it was a disincentive. And then by increasing the tipping fees, it was a disincentive, but it created an incentive for recyclers such as myself to come into the business, because now all of a sudden you could do the right thing and it didn't cost you significantly more. And in fact, it was pretty much the same price.
Yeah, no, that's really great to learn about how, I guess, yeah, how they changed with their incentive programs and how that's really enabled more of it. But no, thank you so much, Dan, for your introduction, and I'll definitely have some follow-up questions for you afterwards. But now I'd like to introduce our next speaker, and that's Hayden Pattullo. And he's just advancing innovation right here in our city at the University of Calgary. And he's a postmaster's student at the University of Calgary, working on just things like construction, building, just like the demolition and just how to divert that and strategies for that. And he's doing it on building life cycle issues using Calgary's office space, the vacant office spaces, as a case study, with robotic fabrication as a possible technique for circular economic thinking in design and construction. And he's also authored Designing Out Waste, and with colleagues Kristen Forward and Joshua Tarrant, and GXN founder Casper Golddigger Jensen. So Hayden, I'm hoping you can tell us a bit more about yourself and the research you've been working on, as well as currently working on as a postmaster student as well.
Hi, thanks so much for having me. So I am a graduate of the U of C's Master of Architecture program, and then I went on to do sort of a postmaster's program in architectural research in the ME-DES, in an ME-DES degree. And so during my time in there, lots of our focus was on creating this publication of Designing Out Waste, which was a culmination of our research and expertise in digital design and fabrication for architecture, as well as visiting scholarship from Casper Jensen, who's an expert in circular design for architecture, and our partner organization, which was Dialogue Design, and some sort of ongoing interest they have in building facades and building material reuse. So I'm just going to talk really kind of high level retrospectively on the publication that we put together and sort of what we found from that and what that process was. So our publication, Designing Out Waste, started out with this idea of Calgary's office vacancy as a main case study, which was to say in 2019, when we did this, Calgary had an office vacancy of about 25%. It's since grown to 29%, so it's certainly not going in a good direction for us. But we essentially looked at that and then looked at the interrelationship between three main streams of waste that we saw in our research in Calgary, which was not only material waste, which we see as the large percentage of solid construction waste going to landfill. In Calgary, we don't have a specific number for it right now this year, but around the world, it's been estimated to be about 30% of total waste as a result of the building industry. There's some pretty sort of frightening statistics as well from the UK about how in many cases up to 30% of building materials delivered to sites are actually wasted before even going into a building. So that's a whole kind of other scale of problem. But it wasn't really just material waste, but the interrelationship between material waste, spatial waste being the office vacancy, the amount of money that's lost in that. You look at the office vacancy in 2019, and just over the few years of recession before that, it had resulted in hundreds of millions of dollars of lost taxable revenue and value from those buildings. So quite a significant economic impact. And then as well as the energetic waste that these sort of problems in Calgary of vacant offices and of kind of like prematurely ended building lives represents, which is energetic waste, not just in servicing a building over its life, but also in the idea of embodied energy. So in our research looking at sort of average building life cycles in primarily the commercial sphere, and thinking about the superstructure of a building, which represents a significant amount of embodied carbon and energy to produce that concrete or that steel, which essentially gives it sort of a mandate to live for a certain amount of time and to be functional for a certain amount of time before it's taken down. And these materials represent potentially hundreds of years of potential use, but in most cases are seeing sort of shorter lives in these commercial buildings than small stick frame timber is in houses. So it's an interesting negative sort of counterintuitive relationship, where you would think that materials such as concrete and steel in those buildings that can live over 100 years would be doing that, but in many cases are not living as long as stick frame buildings, like houses that are kind of only expected to live, half that long in many cases. So that was interesting to look at that relationship, to say that, okay, this clearly isn't just a problem of material longevity or a problem of purely kind of engineering, but also a problem of overall holistic value of in an architectural sense, which is something we're obviously really interested in with our backgrounds. So what we did was we paired with a scholar in residence, Casper Jensen, who founded GXN Innovation and is one of the founders of 3XN Architects in Copenhagen. And those guys bring some very interesting ideas in circularity and circular economy as it pertains to architecture. And they have very close working relationships with many of the sort of founders of that from Europe, in developing those theories and applying them to architecture. So they've got a book called Building a Circular Future that's really interesting and awesome to check out, which is kind of a long, really in-depth look at a number of case studies in circularity in buildings. So they bring a lot of interesting theory in that, in translating from a linear economy to a circular economy in architecture, which is sort of partially differentiating biological and technical nutrients and figuring out how we can create life cycles of materials that separate these two nutrient streams in order to kind of retain value in them. And one thing that is really interesting that they bring to the table in terms of thinking and practice as well is that they're really concerned about value-based material reuse and sort of value-based applications in architecture. And Dan touched on this briefly with viability of recycling of these materials. It's really a really good sort of example is the idea of recycled concrete aggregate from building superstructure, slabs, columns, things like that, which is, technically recyclable. And the most common application is for it to be sort of crushed down and used in road fills for asphalt. But the kind of problem that implicates is that it is a very sort of low value reuse of that material, and the crushing and reprocessing of that material often involves significant amounts of energy and money. So at the end of the day, in many cases, it's just not sort of viable, or at least not appealing for companies that own buildings to kind of put the extra investment into properly recovering these materials, but also not viable for the people that process them to be able to, recover them from job sites, transport them, store them, reprocess them and crush them, and then sort of sell them for kind of pennies on the dollar, when in many cases this material has lived, maybe half as long as it theoretically could in a building. So what Casper and GXN brought was lots of techniques and theory around how we can solve that. There's an idea of the material passport that's really interesting, which looks at the idea of the role that uncertainty plays across scales of building lifetimes, in saying that you're crossing a span of about 50 years, let's say minimum, between a building being constructed and being demolished. And in that time period, you're going to lose almost all your information about the materials that went in that building, in terms of how they were made, what went into them, how they were maintained, what sort of risk factors or events occurred during their lifetime that would affect their value and their reusability. So this idea of uncertainty, they talk about, they introduce the idea of a material passport, which is a component, sort of digital RFID component that can be embedded into building materials, which essentially links that material in physical space to a digital database. So thinking forward, however many years in the future, over time, you can kind of continue to update the material passport for that material to record how it's maintained, how it's made and things, so that at the end of a building's life, if you do have this proposition of saying, okay, these structural elements should be reusable again and should be worth X amount of money for someone doing a new project, you actually have the kind of backing to prove that and to address that. So lots of really awesome theory, lots of really awesome techniques around that we implemented in our Designing Out Waste project. The idea of designing for disassembly, which kind of pairs with some of the ideas I was talking about, in the sense of, again, something Dan mentioned, that material composites and things that can't be very easily physically separated, the viability is essentially gone in putting the sort of labor and techniques in many cases into separating them into their discrete streams of, you know, plastic, concrete, etc. Spray foam is a really good example, just if you're wondering, of something that, you know, anything it touches in a building is going to become that much more laborious to separate from the spray foam to be able to recycle and reuse and clean. So that kind of idea that we're switching from sort of wet cast in place connections wherever possible towards mechanical fasteners that can be easily reversed. They're using easily dissolvable compounds to cast in mechanical connections in slabs and in concrete elements whenever they can, so that at the end of the day, it's much easier to separate that concrete from that metal and break them down, or, you know, reuse them at a one-to-one scale. So ultimately in this project, we also included a case study through our time at Dialogue Design of their McKimmie Tower project on U of C's campus, which many of you may be familiar with. The basic premise of this project was that they were reusing the superstructure of the building, so slabs, beams, columns, which was great and produced a really highly environmentally performing project in terms of sort of sequestering the carbon in rebuilding that stuff, but also in extending the lives of those things that represent a lot of energy. And anybody that's used to looking at embodied energy diagrams of buildings per each of their layers knows that the superstructure and the foundation is kind of the most embodied energy intensive part of the building. So what we asked was, you know, it's becoming more commonplace to reuse superstructures of buildings and things like that, as it should be, but what's kind of the next level of reuse that we can look at in these things, of building material that could theoretically still have value and could be reusable, but kind of needs to be processed in a different way to be reused and can't necessarily be applied at a one-to-one scale. And in our research, we ended up coming upon the cladding material, which was a sort of concrete cladding for the McKimmie Tower, which was in that case being diverted from landfill, but being diverted, as I mentioned, into kind of road crush and things like that that weren't necessarily as valuable. So we looked at that and we embarked on this road down sort of our expertise in digital design and fabrication to ask how materials like that, which require conventionally lots of testing and lots of uncertainty about their reuse, and also are really hard to reuse one-to-one with size constraints and sort of the constraints of design, sort of design strategies when they were made, and how we want to design buildings now. And we applied this process of digital parametric design to them to say, if we were to apply these onto an old, highly vacant office building in downtown Calgary, in order to transform that building and make that space valuable and appealing to the market again. This building in question had sort of a failing envelope, had lots of sort of energy issues around the envelope, and just had very sort of outdated space in it. So we asked how we could take these panels and kind of digitally redesign them to fit this new facade. So in subtracting pieces of them to create new apertures, to create sort of a dynamic facade, kind of a brise-soleil component, for anyone who's familiar with that term. It's essentially a second skin on a building that performs most of your sort of shading load and an extra layer of insulation to avoid the energy contribution to those things in the summer. And then in the winter as well. And we looked at how that could be performed with industrial automated robotics. So in kind of cutting out lots of the labor from that equation and looking at ways in which robotics were starting to be used to test compressive strength of old concrete elements, for example, in order to say that, you know, we talked to Lafarge and people who made those materials, and they sort of determined that many of them wouldn't be reusable or structurally viable, and then ultimately meaning that in a conventional scenario, you wouldn't be able to reuse any of them if you couldn't if there was uncertainty around that. So testing was one issue that we started to look at with using industrial robotics. And then as well, I mentioned subtracting out of these panels to fit sizes of new buildings and to be reused closer to a 1-to-1 scale and closer to a scale where they could retain their original value. And so that was kind of where our research ended up, was taking an architectural approach to circular design and to applying some of the more contemporary architectural tools to be able to reuse these materials and retain value in them. And that's kind of where we're trying to head here in the near future with our research, is kind of continuing to look at those tools and how we can test that and make it more viable to process old building materials in these ways. Thank you.
Thank you, Hayden. I think that's really interesting, especially to see how it ties in with what Dan was saying as to what some of the challenges are. And I think, you know, you were also looking at some of the challenges in other areas like office vacancy spots. That's not something that I typically wasn't even thinking about. I normally think about like the material aspect or like emissions or just how to make it more energy efficient. But I guess to think about space and how it really is like a big concern that we are actually seeing a lot of in Alberta and especially in Calgary right now. And I think just to see that you guys are working on that uncertainty aspect to see how, you know, how we can minimize those uncertainties and how to get better recovery rates and things like that. So I really enjoyed hearing about that. And now with our next speaker, Dr. Godo Stoyke, he'll be talking about some of the designs he's implemented this on for his housing projects. So Dr. Godo Stoyke is a best-selling author of climate solutions and an award-winning environmental researcher and presenter with 2 science degrees from the University of Alberta, as well as a PhD from the University of Calgary Faculty of Environmental Design. And he's also the president of Carbon Busters, which is a sustainability consultancy focusing on deep green, sustainable, integrated community planning, energy efficiency, zero carbon design, sustainability strategy, and environmental education. And he's also been selected as one of the 50 Canadians making a difference by Green Living magazine and has been nominated for the Clean 50 2021 award. So Dr. Stoyke, thank you so much for joining us today. Could you please tell us a bit more about yourself?
Good morning. Thanks, Adrita, for having me. I hope you are, I guess, I'm enjoying the sunny day in Calgary. Apparently it's in Edmonton, it's pretty gloomy, but I'll still try to keep up my spirits. So in case you're wondering about my accent, I was born at the University of Alberta Hospital, so it's clearly an Edmontonian accent. If you're not buying that, it is true though that I did grow up in Germany near Hamburg. Also, I don't eat any meat, so I claim to be the original vegetarian hamburger. Anyway, Carbon Busters was started in 1992, so about 28 years ago, to basically reduce the carbon footprints, but primarily of buildings. And we've worked a lot. At that time, the energy prices were very low in Alberta, much higher, and also environmental awareness was quite high in Europe. So we did a lot of work in Europe with the institutional building operators to reduce their carbon footprint through energy conservation and green retrofits. And in the last, and then about 8 years ago, we also started Sea Returns, which is a nonprofit company that does green retrofits in Alberta. About 10 years ago, we started to move more into, it is great to retrofit buildings, but the best paybacks for high efficiency and low carbon impacts are at the design phase. So it's really when you build a building, you can make easily choices of, a better building envelope, better technologies. It's a lot cheaper than retrofitting. So we started doing more projects in Alberta. And one of the projects we're working on right now is, you may have heard of Blatchford in Edmonton. It's a community, it's a redevelopment of the old airport, the municipal airport. And the goal is to have 30,000 people living in a zero carbon community. And Carbon Busters is building 7 net zero townhouses there. And also, and right now there's 3 left. So in case you would like to have a change from Calgary, you might want to move to Edmonton, you can still buy one of our net zero units. One of them comes with a free net zero townhouse as well. And also, 2 years ago, I finished a degree at the U of C, just like Hayden, or where Hayden is working right now. And it was basically focused on optimizing the design of buildings for zero carbon, and it was a life cycle approach. So basically looking at not just the operational impacts, but also at the materials. And I mean, good examples for materials are, we think of insulation. You can choose cellulose, which is a recycled material. It's one of the lowest embodied carbon of any insulating material. If you go to fiberglass, you're using 6 times as much energy. And if you go to, for example, rigid foam, it can have 30 times the embodied energy per insulation per R value. And if you have blowing agents that are strong greenhouse gases, you can actually increase that by a factor of 1,200, some of them, 1,200 times the impact of CO2. It might take 100 or 200 years to recover the energy from that material. So looking at climate change is one of the biggest impacts we're looking at right now. And for much of that, we actually know the solution already. We have the technology already. Basically, efficiency, of course, part of that is the circular economy is a big part of that. The other part is we really have to electrify all our energy use. So, for example, electric transportation, electric heating. And then finally, we have to use renewable energy to supply the energy. And this way, we can really address a very large portion of climate change. But the circular economy, in some ways, is a lot harder. Because what we're really trying to do is we're trying to get to a state where any waste product becomes a feedstock for another. So it's basically an eco-industrial approach. And if you look at humanity right now, we can turn to where do we look for wisdom? Obviously, the Lord of the Rings by Tolkien, and you can see the different lifestyles of the different races there. You look at the orcs which are cutting down Isengard. So basically, they have a very unsustainable lifestyle. Then you see the elves, they're living in the forest and they maintain their lifestyle without destroying the forest. So basically, our question is, how do we get from being orcs to becoming elves in the way we operate our life? And if you think about the Earth is really a bio-industrial complex. We've had life on Earth for 3.5 billion years at least. And nature has pretty much managed to not accumulate a lot of waste material. I mean, admittedly, there was a switch from a CO2 hydrogen atmosphere to O2, which killed a lot of organisms. But in the long run, Earth has always managed to balance out. And circular economy is basically of going from extractionism to biomimicry. Just as an example, let's think of a spider. A spider produces an industrial product called silk, spider silk, that has a higher tensile strength than steel. And yet it is produced at room temperature in the abdomen of the spider and produces 0 toxic byproducts. And at the same time, the only input it requires are dead flies. So it's something that's very sustainable. Of course, changing our whole industry to be like a spider will take some time. I mean, there's actually a group in Alberta called Alberta Biomimicry, which is looking at ways how we can learn from nature and basically create a circular economy that way. I think actually that's pretty much it. Thank you very much.
Thank you, Godo. Yeah, that's really cool, especially in the biomimicry world. I think it's so cool that, the solutions are kind of just out there, but we haven't exactly figured out, like we kind of complicate it, right? We process these more complicated materials, but then I guess that's how we got a lot of things like airplanes and things like that. So it's really cool to see that we can still look to nature-based solutions. And for our last speaker today that I'd like to introduce is Kamran Faisal, and he's an environmental specialist at the City of Calgary in the Transportation Infrastructure Department. And he works with his team to ensure compliance with all the regulatory environmental requirements. And he has experience in a wide range of areas in environmental management systems, environmental site remediation, environmental risk assessment, and environmental permitting and regulatory approvals. Kamran, could you please introduce yourself to the audience today?
For sure. Thanks, Adrita, and good morning, everyone. Can you guys hear me okay? Yes?
Yes.
Okay. Okay, so as Adrita mentioned, I am an environmental specialist with the Transportation Infrastructure Department at the City of Calgary. Just for the understanding of the audience, transportation infrastructure is one of the department in a bigger picture with the transportation division of the city. Our department's main role is to build large transportation infrastructure projects. That includes roads, bridges, LRT lines, storage yard for buses and LRTs. Majority of our projects are new construction, but we also do improvement projects like road improvements, etc. With these large infrastructure projects, there's usually larger footprint. They have larger footprints and more land is disturbed. So obviously with that disturbance of land, there's some sort of environmental impacts. Now, my role with the Transportation Infrastructure Department is to make sure that we not only minimize these adverse impacts to the environment from our construction projects and activities, but also to make sure that we are in compliance with all the regulatory requirements for our project. In order to meet these environmental requirements, we have different programs and procedures that we have implemented at our department, and that's not only in the planning and design phase, but also a major part of that is in the construction phases. That basically helps us in addressing and minimizing these various environmental impacts. Now, these programs, they are from due diligence programs like site investigation and biophysical impact assessment studies during planning and design to environmental construction operation plans during construction. Our department, we have an active environmental management system. We are certified under the ISO 14001 standard, which is an international environmental management standard. And our environmental management system, basically it works as an umbrella under which all these different environmental programs and procedure works. So I guess just also quickly wanted to mention that some of these programs, they are basically a requirement under various regulations, but some are basically initiative from our department to further improve the environmental condition, and that's being basically a good steward of the environment. So recycling and diversion of the construction and demolition waste material is one of that initiative from our department. And we basically, we found this as an opportunity that we are able to collect that C&D waste material and send it for recycling. And this is basically based on the nature of our activities that we do. We deal with lots of asphalt and concrete. In fact, it's more than 90% of the C&D waste that's generated on our project site. We saw this opportunity that these materials can be recycled. So why don't we introduce some programs under which the contractors who are basically building these projects for us, they are obligated to basically collect this material and send it for recycling. Some of the other streams that are basically generated on our C&D waste that's generated on our project sites are metal, wood, cardboards, and plastic, but the amount in terms of percentage is quite less. The major portion is the asphalt and concrete. Now, I guess just to clarify a little bit, when I mention C&D waste, it does not include any garbage or municipal waste. It's only the construction and demolition waste that's generated on our projects. So for us, as the city department, different contractors basically build these projects for us, and we have these programs that basically makes the contractor to collect, segregate these various types of C&D waste streams, and then these materials are sent to various third-party vendors for either recycling or reuse. For example, concrete or asphalt, it's even sold as aggregate material. I believe now like market is a little bit less for that, but it's being sold as aggregate material. From the last few years, I guess just more specifically to our department at the city, we've been able to collect and recycle, send the C&D waste material for recycling. More than 95% of that material that's been generated on our project site. This is something obviously we've achieved by several years of plannings and refining our various environmental programs. We also introduced several clauses into our construction contracts that the contractor is required to separate these different streams of C&D waste. And then with the implementation of several environmental programs like the Environmental Construction Operation Plan, it's been strictly implemented on the site, and then the contractor were basically obligated to send these materials for recycling. We also have a very strong monitoring and audit program in which we basically continuously monitor the C&D waste material that's generated on our site to make sure that it's being segregated and then sent for recycling. So I guess just to sum it up, we are a good example that with the implementation of some of the best management practices, a major chunk of our C&D waste is collected and then sent for recycling or reuse. Thank you.
Yes, thank you, Kamran. Yeah, I think, you know, what I really like about spaces like this and just these clubs is earlier, like Hayden and I were chatting and we were just saying like there's a lot of different people doing work in this area, but we might not always be aware of who's doing what. And I think our club is our club, and I guess similar clubs like this, is to just promote that, you know, this is an area where everyone can kind of meet each other and hear about the different solutions that are happening. Like, as we've heard, like it's been from many different, like people are tackling it from various angles, whether it's innovation, company policies, or, you know, just in our businesses. But here, like actually finding out that so many cool things are happening in our local city, I think that's the really exciting part about all of this. So I guess my first question is for you, Dan. You were talking about, you know, some of how like we take our products and how it's converted into a new product. Sometimes it's directly converted into that same product, but sometimes it's something else. And I guess I was just always kind of curious to know, like, you know, when we put things into our blue bin, how much of it is actually getting recycled? And I've always been a bit skeptical of it. So just to hear that, you know, we've made a lot of progress on that, but maybe not completely due to the different, like how it's hard to separate out composite materials. So I guess I'm wondering, like, is there something else we could do in the initial stages? Like, I guess beyond just maybe, like I guess there's the initial design of the materials, but is there something else that we could have done to simplify the later steps, the sorting or anything like that?
It's more on the downstream side, but one of the things that we learned early on is training the trades, the haulers and the builders, that when they is to obviously reuse as much as they can on their sites, and some are quite good at it and some are less so. But secondly, is when we're collecting it, is to have those materials put into, again, the curse that we have in our society is we like things easy. And that's why we all throw it into one big blue box and multi-stream, and everything goes in, and or single stream, where everything goes into that box. We have the same challenges in the construction industry. When everything goes into that box, it's difficult to pull it all apart again and to sort it all out. So what we did early on is we worked with the drywallers and the haulers and said, we'll put out a drywall bin. And while you're doing that, yes, we know you get plastic and a little bit of insulation and the mud pails and all of that. Put that on top, so that when we come to sort it, they unload the load, we scrape off the garbage off the top, almost mechanically sometimes, pick it off, and then we can use the rest of the drywall quite easily. We did that with shingles as well, where we worked with the roofers, and we used incentives and disincentives. If they were willing to work with us, there was a financial benefit if they helped us with that. So while we can still recycle those pallets with the roofers and some of the plastic, it makes it a lot easier if you can put all your shingles in your load, clean up your site, and then put that stuff on top. And even if you bagged it and it was garbage, it makes our job a lot easier and more economical and sustainable. So one of the challenges that we're having in the bigger picture is keeping that material in those individual streams, if you will. And then that, in the whole residential component, that's, if you have to have hundreds of people sorting out that material by hand or optical or mechanical, it's very difficult to do. Whereas if you can do it, and have your bins labeled, and I've seen construction sites, not as much anymore, but back when we first started, you would see 4 or 5 or 10 different bins all labeled nicely, and this was for this was for cardboard, and this was for plastic, and this was for whatever, and it worked quite well. It's difficult to do. You have to be very organized, and sometimes that chunk of metal that goes into the wood bin, you kind of scratch your head and wonder why they put it in a wood bin. But anyway, so that's one of the things that I find one of the best ways to do it.
And like, do you think for our individual, like at home, for example, like when we throw things out, like, do you think we should be, not just having one blue bin, but that should be further broken down into like a few different recycling bins? Would that help with anything, do you think?
Well, that's my personal opinion is that multi-stream is easier. I even like it. I throw everything into my blue bin. In the old days, when you had to, individually sort your newspaper and your plastic and all that, they had a lower percentage of people that did it, but they had higher recycling rates and less garbage and less, more of that material was recyclable because people did separate that. But I think in North America, our society is going back the other way to a single stream just for convenience. And I know when they introduced it in Calgary, I don't want to speak too much to it, but when they introduced the single container, a lot more people got involved in recycling just because of convenience. They didn't have to, sort it all at home. But as a recycler, it is more difficult.
Yeah, and so Godo, I'm hoping you can kind of tell us a bit more on, for example, like Dan kind of touched on earlier, like how, it reduces maybe the quality of some of the products depending on what it is, and sometimes it's just not worthy of being reused again, or we haven't found the solution. And since you've kind of worked with a lot of different types of materials in your builds, could you maybe tell us about maybe like how we can improve the performance? Like you explained how biomimicry is one of the ways to look at new material designs, but is there a way to kind of extend the performance or make it more usable?
Yeah, I think there's a number of approaches. I mean, one of them is not to have the waste in the first place. So right now we have a lot of single-use plastics. I mean, that's just insane. Those can be basically virtually eliminated by reusable approaches. In the building industry, we're looking at rapidly renewable materials. So, for example, materials made from straw and from hemp in Alberta. But right now, even though we're working with a researcher here in Edmonton who is kind of a pioneer in this field, who's trying to create cars from using panels made from hemp, for example, they are still not widely available. So it is pretty tough. Because another approach is when you're doing a building, you can look, what Hayden mentioned is, durability. He was saying, ironically, where we use steel and concrete, which is long lasting, they get torn down every 20 years in some cases. And homes, which actually tend to have a fairly good lifespan, we often don't look at durability. So sometimes when we design, we will actually pick a material that has a slightly higher carbon footprint, but has a longer lifespan. So that is another important consideration. And then there are some, as I mentioned, some materials like cellulose. You can't use it under the house or sometimes in basements, but wherever we can use it, we use a material that is from a recycled source. And I think LEED has to be given a lot of credit for that and increasing those building materials in the industry, because even though LEED is a bit weak on energy and carbon, it definitely emphasizes using locally sourced and recycled materials. So I think that's really good. Yeah, I had another point, but I forgot it right now.
Oh, okay. No, yeah, and I was going to say, because you touched on the LEED certification, and I guess for the professionals in our audience, like, I'm wondering, is there any other type of material certifications that could play a role in trying to promote these type of recycled products and getting more of their testing into place? Or maybe, Hayden, you could touch on that too. You kind of looked at the testing aspect, but I guess I'm wondering, like, if there's any sort of certifications or, yeah, like testing procedures that could further the like research side and working on their performance.
I think maybe a good example to speak specifically to that is to look at, we actually have engineering standards in North America for the amount of virgin aggregate that has to go into cement for new sort of construction, concrete, asphalt, things like that. We actually have a set number for that, and I don't recall off the top of my head what it is. I believe it's less than 20%, which is sort of based on kind of old engineering testing about the compressive strength of concrete being negatively affected by virgin aggregate. However, I think the important thing is to be able to readdress things like this, like sort of legislative and standards-based things that are kind of hindering reuse of materials, whether it's that or in the building code, because recently in Europe, like as they've continued to experiment with recycled aggregate in projects, they've successfully reused or developed new asphalt with up to 70% recycled aggregate without a significant cost to its compressive strength. So I just think going back and continuing to develop research on those things is really, really important for those to move forward, whether it's there or, Canada's building code is really sort of a model for around the world for many good reasons, but it also makes it much, much more difficult to reuse building materials, to embark on renovation projects. Like I've actually been a practicing designer for the past year, and we do lots of renovation projects, and the value proposition for building owners and the reason you don't see more kind of superstructure reuse is that you're often spending as much or more money as creating a new building just because you're involving testing and uncertainty, so much uncertainty around existing materials. So I think the more we can kind of prove safe reuse and prove that you can track these things over time, the better. Like there's a really good example, I think, of Michael Green architecture in Vancouver, which is kind of, he had this idea of using heavy timber for tall buildings, which was basically illegal. And people said, you know, engineering wise, fire code wise, like it would never work. And he, you know, embarked on all his own research to kind of prove that wrong and to prove it was a valid and viable way to create tall buildings. And he eventually got the laws changed around that. You can build, you know, tall buildings out of heavy timber now in Vancouver and in many other places. So stuff like that, I think, is an onus on us to take on some of the research ourselves and testing ourselves to be able to overcome at least some of the official kind of red tape and misconceptions around material reuse and quality.
And
Dr. Gobo, were you putting your hand up?
Oh.
Yeah, actually, sorry, I did remember one of the points I want to make, and that I think is the problem right now that we have. I mean, some recycling components have been very successful. For example, if you look at lead, you know, 97% of lead batteries get recycled, very successful. Aluminum cans, a recycled aluminum can takes 25 times less energy than a new one. But then there's other areas like plastics, which is almost a complete disaster. And 90% of the plastic goes to the landfill, used to be shipped to China. So I think what we really need in Canada is incentives for manufacturers to use recycled content and make it mandatory, or basically put a virgin material tax on materials, because if you don't have a market for the recycling, it's not going to get effectively collected and sorted. So I think this needs to be driven by a market where we actually reuse materials so that there's incentive to actually use those. And I think that will be a big step for moving towards a successful circular economy.
Mm-hmm. And yeah, so I'm wondering more about, like, me and Aaron were kind of talking about like the biomaterials aspect that you used in your projects. And I'm wondering, like, what's the non-circular aspect of the materials that we use now?
Sorry, what do you mean?
Like in just some of the materials we use now, like, for example, I mean, like in terms of plastic, we know how that's like not very circular, but like, I'm wondering, what are some of the common materials we use now? Like I guess you mentioned like the products you have, they have a bit of like higher carbon content, but they also have longer lifespans, which is what makes it more circular and more energy efficient. But I guess what I'm trying to know is, for the products we use now, how are they different? Is it just that they have lower like length of life, or?
So several. I mean, one is the embodied energy component, which I mentioned. So how much energy does it take to make it? In terms of the biomaterials, if you use something like hemp or straw, for example, it gets produced, and some of it is needed for soil amelioration, but it grows in a year compared to wood, which takes decades to grow. So if we can replace some of our wood products with biofiber that's from other sources, and often as a waste product in industry, in agriculture, for example. So that means that's a lower footprint. Some of the other ones, I think what Dan talked about is, is a lot of it, once you're at the end phase, decommissioning of a building, then you're looking basically, how do we separate it? Are we effectively recovering that material? And I think, as also Hayden mentioned, that is often not happening yet, right? I mean, it's very commendable that that the city of Calgary has achieved this 95%. I mean, that's incredible of returning the materials. And Edmonton used to have a very good program in terms of waste management. It's faltered a little bit because recently we're trying to create biofuel from some of the waste in the facility we have right now. It's not really working that well. But I think those are some of the ways we could increase the circular economy stream.
Mm-hmm. And also with the community planning that you're doing, for those townhouses, like, is it just how the houses are designed, or is it the entire community? Like, what else are you putting in your communities?
Right. So the community, for example, is designed to be very pedestrian and bicycle friendly. So there's wide bike paths. There will be an LRT station, or the transit station in the community. And there will be virtually no or very little above ground parking allowed. So I mean, those are some of the ways we can reduce the overall carbon footprint. I don't think there are a lot of standards in the Blatchford Building Code, not as much for recyclability. It's more a focus on energy efficiency itself.
And actually, I'm quite surprised about the 95% here in Calgary for the C&D. So like what is it measured on, or how are we tracking that? And I'm guessing, like, what are some of the ways Calgary's hoping to further improve those practices?
So I guess 95% is the material that's being recycled from, specifically from transportation infrastructure projects. At the city, there's obviously other departments. They are not to that level. And I guess the major, one of the major reasons why we are able to achieve this 95% is because of the type of activities that we have and the type of material that we deal with. You know, collecting concrete and asphalt and sending it to recycling is way much easier than any other building material. For example, you're collecting from demolition of the building. So I think that one of the major reasons why we are able to achieve that target is due to the type of material that we are dealing with. And I guess the other thing in terms of, I guess the other portion where how we can do better, we basically achieved this. We had certain environmental programs, but we during the last few years, I guess we further improved those. There's a lot of efforts that's been done in terms of educating the contractors, working with them so that they understand our expectations, and it's been filtered down to all of their employees and subcontractors. And I think it's kind of a mutual working with those contractors. And once these contractors, like they work with us on several projects. So once they work with us on one project, they understand our expectation. They go through that process of recycling and collecting material. On the next project, it's much easier for them to basically adopt that strategies. And we are always there in terms of helping them out if they need to further improve that process of sorting. So I guess one point I would like to make is that I believe Dan was making that comment, is that you know, recycling and sorting on the site before it goes to the third party. So on pretty much all of our project, we ask our contractors to basically separate those streams on the site. So when it leaves to the site, it's either asphalt stream, it's either concrete stream, it's a separate metal bins, which goes to basically metal. So I guess there's a lot of work that's done on our site that's make it much easier than on a third party vendors when they receive that. They really don't have to resort it.
Mm-hmm. Okay, yeah, no, I think especially like we've been hearing, like just with concrete and steel and things like that, it's a lot easier, but I feel like there's still a lot of research that needs to be put and different applications. And actually, sorry, before I continue, I think Godo, you had your hand up for something. Oh, you're just giving the thumbs up. Okay.
Yeah, before we proceed any further, we did have a poll to just get a feel for who else is on the call today. And I was wondering, Lori's going to pull that up. If people wouldn't mind taking a few minutes just to fill it out, it's nice to see where everybody is coming from.
Nonprofits and government, yeah. Students. And we have a bit of, yeah, we have almost every single box covered. So that's.
Yeah, this is great. It's a nice mix of people in the audience. And yeah, I just want to reiterate, you know, we're planning on having feature sessions on various topics, including this one. So If you are a speaker who's listening today and you want to share your knowledge with our group, we would love to have you as a feature speaker. So please reach out to us at Circular Economy Club @gmail.com if you are interested in presenting. Wondering, Adrita, did you have any more polls that you wanted to do before we get to audience questions?
Yeah, actually, so I had one, like, I guess Godo touched on it, what he thinks is one of the biggest barriers, but I'm actually curious to hear from all of our speakers, just what you think is the biggest, like, yeah, like I was just hoping you guys could all touch on what you think would advance Alberta's circularity or Calgary's circularity, and what's the greatest barrier and opportunity. And so I guess I want to hear from you, Dan, first.
Well, I kind of anticipated that question. Better upfront design, better sorting of materials, an improvement, and I think a few of the speakers touched on this, an improvement in the end user value of the recycled product, perhaps by requiring minimum recycled contents, green procurement policies to buy recycled materials, and then also in changing some of the engineering and building codes to accept some of those materials as a product. I think all of those are kind of important in the overall picture, and any one of them in its isolation probably isn't going to be that effective. You almost need to, stimulate the marketplace a little bit with incentives and disincentives, and I think those 3 or 4 different things would probably achieve a good portion of that.
Mm-hmm. Yeah, and I always also wonder, like, is it incentives that work better or is it fines? But
Both.
Yeah. And so, yeah, now what about you, Hayden?
I think speaking to it from the design side, what I'm most interested in and what would probably be the most beneficial is if architecture and design started considering how to design for broader scales of time and design for not just kind of this initial really great building or anything, but for, a building that was eventually going to be broken down into different materials and components someday, and how that lives and contributes beyond the life cycle of that building. And we have, for many recycled materials in Canada, we have end of life legislation that says, if you design those things and you create them, you have to have a plan for what's going to happen for them at the end of their life, how they're going to be reprocessed, reused, or broken down or disposed of. Ironically, I think unless it's changed recently, from my understanding, we don't have end of life legislation for plastics in Alberta. Maybe Dan can clarify that, but I think things like that are types of thinking that we should start applying to buildings, because they are such a massive contribution to waste, and start thinking about how we can reduce uncertainty and information lost over a building lifespan, to be able to think about it as a set of materials and not just as a building that's going to live and die.
Yeah, Hayden, you touched on, and I think the term is probably is a couple different terms, but extended producer responsibility. And I know.
Yeah, sorry, that's a technical one.
Yeah, and on last Friday we had the minister and a couple MLAs at our plant here in Bashaw, and that was one of the final tours, if you will, COVID friendly, of course. One of the tours that they did, and then on Monday they introduced one of the MLAs, I believe it's from Stony and Spruce Grove, introduced an EPR bill, and that has just hit the floor. I believe it was on Monday. So timely is that, they were wanting to make sure that there was those opportunities and it existed in the Alberta landscape. But that was kind of one of the things that they have just introduced, or they're introducing. I believe it was just put on the floor on Monday.
That's awesome. That's very exciting to hear. I know with our research, that was like a big surprise, was like Alberta's the one place that doesn't do this. It's funny in the broader scheme of design, the field's only, I would argue, really starting to look really heavily into the idea of logistics as it relates to projects. But I mean, I think where the industry has to go is kind of considering the idea of reverse logistics eventually, which is, you know, this thing exists beyond its immediate use scope. How are we going to design for that? Gary, I think you muted yourself when you meant to do the opposite.
Sorry, that was me, Gary. There we go, Gary.
Okay, this is my preference, Gary. I don't really care what you're saying.
I don't think
Hey,
he's
bye,
able
Gary.
to talk.
Anyway, I was done, but I appreciate the discussion with you, Dan. It's really insightful.
Thank you.
And I'm glad that's happening.
Yeah, and now I guess I'm hoping, Kamran, you can tell us a bit more about what you think some of the barriers, opportunities, and also like who do we advocate with if we want to take it to the next level with City of Calgary? Like the transportation department's doing great, but what about, you know, the other departments, and who can we talk to?
Sorry, thanks. So I believe it all depends on the different streams of waste that's being generated. You know, more specifically, I guess you talk about the city and their different their different departments. But I believe we all are in this. So all the stakeholders that's involved, including industry, government, consumers, even research institutes, I guess, how we can further improve the diversion and I guess the reuse. So I guess one thing I specifically wanted to talk, and more specifically in terms of our stream of work that we do. So for example, even when I say we recycle the asphalt more than 95%, and this basically relates to, you know, that there's probably more research needed for what type of recycled products that we can use, especially for our stream of work. So the City of Calgary specs, and I believe this is for probably other municipalities and Alberta transportation as well, is that they allow only 20% of use of recyclable asphalt. And this is majorly due to the reason that, you know, the most important thing in our work is the structural stability of our asset. We obviously don't want to compromise that. And for example, in terms of the road pavement, it has a life of more or less like 20 years. Now with this 20% use of recycled asphalt, the research and the data, it kind of shows that it meets that structural stability, and we can reach that 20 years of life of the pavement. But if we increase that percentage of the recycled asphalt, it basically impact the structural stability. And then of course, you know, in our the area that we are living, you know, like in Alberta, the cold weather is the major factor that basically affect that. So it kind of reduces the life of the pavement, and definitely there's more research needed that we can basically introduce, you know, that sort of recycled products that can improve the structural stability, like especially in our case, and then it's going to make it much easier than for the government, like for us municipalities and other users of that, to basically introduce that into construction.
Hi, Adrita. I also wanted to take a couple questions from the audience, and there were a couple comments about a materials bank for construction materials, or trying to tap into the municipal recycling program. I'm not sure, Kamran, if you're able to comment on that at all.
Sorry, can you repeat the question?
Tapping into people being able to access the municipal recycling program to reuse materials. I'm not sure if you can comment on that.
Yeah, I'm not sure. I think that's probably the waste and recycling department that basically deals with that.
Or maybe Dan, maybe you have some thoughts on that.
If you Google Calgary Materials Exchange, I was one of the founding members of that very idea about 15 years ago. It then became Green Calgary, and I believe there's still an organization. I haven't been involved in the last few years. It has those types of forums do exist. There was a free Calgary or a free exchange. They do exist. Their overall impact is difficult to assess, and on a diversion rate is probably not that great. But I mean, it's kind of a take it or leave it program almost for that. So it has limited impact, I guess.
I'm just going to share the final slides that we have. Just let me do that because we do have some resources that we want you to be able to access. And maybe Adrita, you wanted to touch on these next steps as well?
Yeah, like I guess today we've kind of heard about from different speakers on what some of the challenges are and what some of the what some of the opportunities are. But actually, I'd like to first do our poll, the second poll question. I kind of want to just hear about from our audience now, like what do you guys think are the most, what will advance our circularity? And I guess I'd just like to say I took out policies from this because everybody always chooses policies, and I think, you know, that's always kind of gonna lag behind. So I want to see what else we could do. Increase, yeah, okay.
Big tie.
Yeah, and I agree, like that's exactly what I would have chosen. But yeah, so that's why we kind of wanted to give you some of these like next steps. Like one of the things we have is Reconstruct YYC. They're one of the local NGOs, and they're part of the University of Calgary, and they actually wrote a letter to increase construction diversion strategies. So if you guys have time, it'd be great to do that. And, you know, there's many other things you can write to your local government about, maybe something regarding incentives and things like that. But here's a few other resources I just put on. But I think one of the main things is really thinking about how it applies to other areas in your life and just from everyday decisions. Yep, and Erin just put the link there on the chat as well. And then we have our very final slide, which is just more resources about our panelists today. And we actually, what we're going to be doing is providing like a short survey. And we're also going to be providing just a big link and resources because we couldn't put everything on this presentation, but there's a lot more books and research papers and websites and things like that that we really want you guys to check out and stay tuned. And so today I'd really like to thank our panelists for taking the time out of their day to tell us more about what's happening. And I really enjoyed learning about, you know, not only like what's happening, but also who we can look to and what kind, and just keeping up with the work that you guys are doing and learning more about that, as well as future sessions on other topics like, you know, things like e-waste. And we're also really curious to know, like, you guys got very involved in these types of careers, but a lot of people might not know about what kind of green careers there are. So we'd like to do some sessions on that as well. So yeah, thank you everyone for joining, and just please stay tuned and follow us on social media to keep up with our future events. And just one final thing is tomorrow is UN's World Cities Day. So that's kind of, again, why we had the Circular Cities Week.
Thank you.
Lori, is there anything else you'd like to share?
No, just that the videos from last week and this week will be posted this weekend. So if everyone missed the meeting that we had on Monday that was on Circularity 101 or Circular Economy 101, and this video as well will be posted out so people can share or rewatch this event.
And Lori, is that just on Facebook, LinkedIn, or everywhere, I guess?
good question. That's an answer for Aaron. I'm guessing it's going to be on Facebook for sure.
Yeah, we'll figure it
We'll
out.
sort that out and we will let you know, but please stay tuned. Check out our Facebook page and follow us. We hope to do more events, not just on this topic, but on other circular economy topics. So it touches so many different industries, and we recognize there's a lot of experts who are here even just listening today. So hope that we can involve you in some of our future sessions as well. Thank you everyone for making the time to be here.